Hello everybody, so today we are going to be starting the chapter chemical bonding. So it is part 2 of atomic structure. So this chemical bonding, the concept of it is quite easy and it's also a pretty scoring chapter. What we need to pay attention is some basic definitions, some basic, orbital structures, and we have to learn how to draw things in this chapter, right? So we're going to be asked to draw various structures, and that's what we're going to be focusing on. So before we get to the Lewis structures, let's first get to the basic theory of this chapter, and let's wrap it off within 10-15 minutes. So let's begin. First of all, what is chemical bonding? Now let's start from the basics of it. If you look at two elements, say you have two elements, you have sodium and you have chlorine, right? So where is sodium on the periodic table? If you look at the modern periodic table, you see that the atomic number of sodium is 11, correct? That means the thing you need to focus on is that sodium has a valency of 1, whereas chlorine, which is the 17th element of the periodic table, that has a valency of 1 as well. So in order for them to form a compound, in order for sodium and chlorine, when does it form a compound? When it forms NaCl, right? When it forms common salt. So when common salt is formed, NaCl, that means sodium donates 1 electron to chlorine in order to form a stable electronic configuration. Because when sodium gives away 1 electron, it has 8 electrons in its outermost shell. Correct? That means it has a stable electronic configuration. Similarly, if you look at chlorine does not have a stable electronic configuration. Why? Because its outermost shell has 7 electrons. But when it receives an additional electron from sodium, it completes its outermost shell. So that is how NaCl is formed. So when NaCl is formed, sodium basically gives away an electron and chlorine gains that electron, right? So sodium basically becomes electropositive because it loses an electron, whereas chlorine becomes electronegative because it gains an electron. So based on that, we have our chapter chemical bonding. Now, of course, there's different types of bonds. Now, how do you really define chemical bonding? So chemical bonding is defined as the force acting between two or more atoms holding them together to form a stable molecule. So now we have various elements, right? We have monoatomic elements, we have diatomic elements. Say for example, hydrogen. Hydrogen is diatomic. That means for hydrogen to be for the formation of a stable hydrogen molecule, we never just say H, right? We always write H2. The reason being, hydrogen is diatomic, which means it needs two atoms to form a stable hydrogen molecule at all costs. It needs two hydrogen atoms, right? So that is basically bonding, and the concept of it is known as chemical bonding. So that's what we're going to be studying. The first thing we have to remember is that noble gases have a stable electronic configuration. If you look at this, you see a list of all elements, right, on the periodic table. If you look at the first noble gas, we have helium, next we have neon, and next we have argon. So these three elements that you see on the periodic table, they are noble gases. We have helium, neon, argon, krypton, etc. So these elements that you see, they have a stable electronic configuration. That means they neither have to lose an electron or gain an electron. Why? Because they have 8 electrons in their outermost shell, right? So that applies to all noble gases. So based on that, we have two rules that we have to follow. Number one is known as the octet rule. Now, what's the octet rule? The octet, from the word octet, we know that is something related to 8, correct? That means there's 8 electrons. So the octet rule basically means that a noble gas has to have 8 electrons in its outermost shell, right? It always has to have the maximum number of electrons that can be in an outermost shell is 8, correct? So there cannot be more than 8 electrons in the outermost shell. But there's also the case of helium, where helium can only hold 2 electrons in its outermost shell, right? That is known as the duplet rule. So we have two types of rules. We have two rules, the octet rule and the duplet rule. So first we have 2 electrons in the first shell. So 2 electrons in the first shell, that is the outermost shell, for example, helium, that's the duplet rule. Next, we have 8 electrons in the outermost shell, like noble gas, so this helium, that is the octet rule. So these are the two rules you need to remember, the octet or the duplet rule. They usually come with definitions, so all you get to distinguish between both of these on bunch of examples. So if you give an example of octet rule, it can be any noble gas that you have, right? For example, you have argon or you have neon, right? But if you look at the example of, but if you take a duplet rule, you have helium, that's it. So these are the two rules. Now coming back to our basic topic of chemical, as I said, all noble gases have a stable electronic configuration, right? So what does that basically mean? That means that they even have a zero valency, right? Valency is what? Valency is basically the electrons that you can either lose or gain to form Now, another thing you need to remember is that covalent bond can further be divided into certain types of bonds. Like, for example, covalent bond can be divided into polar and non-polar covalent bonds. Now, what's the difference between polar and non-polar covalent bonds? That this isn't really important, but for you to just understand, in polar covalent bonds, there's an unequal share of electrons. Whereas in non-polar covalent bonds, there's an equal share of electrons. So mostly the bonds that you're going to be studying under covalent bond, they are all examples of non-polar bonds. Like if you take the bond of hydrogen, right? If you take a bond of hydrogen, if you take a bond of oxygen, all these are non-polar covalent bonds. Okay, so firstly we have our electrovalent bonds. Now, as I told you, an electrovalent bond basically takes place between a metal and a non-metal. Basically, a metal donates its electron to a non-metal in order to form a stable compound. I already gave you the example of NaCl, which is common salt. How is that formed? So you can clearly see sodium is giving one electron. Sodium is giving one electron to chlorine. Now, when you're drawing these Lewis structures, I suggest you draw them, practice them 2-3 times because every dot here matters. Okay, every dot here counts for something. So you cannot just draw these roughly. These are really important. When you have more than one element in a Lewis structure, always label one of them as X and one of them as dots to differentiate between the atoms, right? So you have sodium here. Sodium donates one electron to chlorine, forming NaCl. So obviously sodium becomes electropositive and chlorine becomes electronegative. Why? Because chlorine is gaining an electron, right? So this is how you draw the bond. Next, we have formation of MgCl2. So magnesium is after sodium, right? So if we have sodium and then magnesium, right? So magnesium has 2 electrons, and MgCl2, Chlorine has 7 electrons in its outermost shell. So 1 electron of magnesium can go to chlorine, whereas the other electron of magnesium can go to the other chlorine, right? So as you can see here, 1 electron of magnesium is going to the first chlorine, whereas the other electron of magnesium is going to the other chlorine. So it is forming. So this is basically how it is formed. So as I told you, the chlorines are gaining, right? They are gaining electrons. So both the chlorines will become electronegative because it's gaining. And magnesium is giving both its electrons, right? It's donating both its electrons. So it becomes electropositive. So it is 2 plus. 2 plus ion is what is formed here. So this is the formation of MgCl2. You'll be asked all these for 2 markers, so please practice them very well. Next, we come to the formation of calcium oxide. Again, the first thing, the strategy to draw these efficiently is to just remember where they are on the periodic table. So if we look at calcium's atomic number is 20, right? That means calcium has 2 electrons in its outermost shell. Calcium's electron configuration is 2882, correct? So it has 2 electrons in its outermost shell. So when an oxygen has 6 electrons in its outermost shell. So if calcium loses 2 electrons, and oxygen gains 2 electrons, won't both of them form a stable electronic configuration, right? So that's why calcium will give both its electrons to oxygen. So the first electron of calcium is going to the first oxygen, and second electron of calcium is also going to the second, also going to the oxygen. So it forms CaO because there's no additional electrons, so it's just forming CaO. So calcium is giving 2 electrons, so it becomes electropositive, so 2 plus. Whereas oxygen is receiving 2 electrons, so it becomes 2 minus. So these are all your electrovalent bonds. Okay, we only have 3 electrovalent bonds in your syllabus, so know how to draw these really well. Next, we come to covalent bond. Now, what exactly are covalent bonds? As I told you, covalent bond involves sharing of electrons, right? It's very simple, just sharing of electrons. So, covalent bonds generally take place between 2 non-metals, right? 2 non-metals. Like, for example, you have just chlorine, right? Chlorine is diatomic, so chlorine needs 2 atoms to form a stable molecule. So, we have the Lewis structure of chlorine here. So, chlorine basically has 7 electrons in its outermost shell. That means it does not form a stable electronic configuration. But chlorine also has 7 electrons in its outermost shell, right? So, we take even numbers. So this first thing has 6 electrons here, and this has 1 electron here. Similarly, this has 6 electrons and 1 electron. So the additional pair of electrons, are taken together to form a single bond. These are taken together and they form a shared pair. So this shared pair of electrons is basically this acts as your shared pair. So let's count the electrons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 electrons being are present here. But how many shared pairs we have? We just have 1 shared pair, right? So 2 more electrons. So that means 12 plus 2, which is 14 electrons, right? So how many lone pairs we have? If we look at the lone pairs, we have 6 lone pairs. Whereas if we look at the shared pairs, we just have this particular shared pair, right? So these can be additional questions you can be asked. You can be asked either to say the number of lone pairs or the number of shared pairs. So I hope you understood the concept. So this is how chlorine is drawn, right? Similarly, we have hydrogen. Now, just like we studied in the hydrogen chapter, hydrogen has similar properties to all your halogens, like chlorine, bromine, all these halogens, right? That means hydrogen has to be diatomic in nature. Hydrogen has to have 2 atoms. Hydrogen has to have 2 atoms to form a stable molecule. So we have the first electron for hydrogen, and we have the second electron for hydrogen. So these electrons are forming a pair, a single pair, right? And this is basically how your structure looks like. So we covered hydrogen, we covered chlorine. Next, we come to oxygen. Oxygen is very easy to remember. There's just 6 electrons in the outermost, right? There's 6 electrons here, there's 6 electrons here. And how many electrons do they lack? They lack 2 electrons, right? If this has 2 electrons, it will become a stable molecule. Similarly, if this contains 2 more electrons, it becomes stable. So there's 2 pairs, there's 2 shared pairs that are formed, right? 2 pairs of electrons that are formed. So this is very easy to remember. Like basically, one trick I use to remember these is that this is obviously a double bond, right? This is a double bond because there's 2 pairs of electrons that are being shared. So if this is a double bond, how I remember it is that you take any element, like for example oxygen, just take 4 electrons. This oxygen has to gain to become stable. It has to gain 2 electrons, right? So that many pairs will be formed, that many bonds will be formed, right? Like over here you have hydrogen, so oxygen has to gain 2 electrons in order to become stable because of the octet rule, right? The octet rule states that there can be a max of 8 electrons in the outermost shell. This only has 6, so it has to gain more. That means that many bonds it will form. Okay, that many. So it's on the double bond. So this is how you need to draw the structure. It's quite simple, quite easy to remember. Similarly, comes nitrogen. Now nitrogen is also very easy. It has an atomic number of 7, right? That means we completely ignore the first 2 electrons. Remember, when you draw these Lewis structures, you do not draw the first 2 electrons. You just look at the outermost shell, the valence shell. You do not look at the first 2 electrons that are there, right? We don't look at them. So in oxygen, we have 7. So that means how many electrons are there in the outermost shell? It's 7 minus 2 because 2 electrons are in the first shell. So we don't consider that. So 7 minus 2, which is 5 electrons. So 5 electrons here and 5 electrons here. So out of them, 3 electrons are being shared. Because why? Because nitrogen has to gain 3 electrons, right? Because nitrogen has how many electrons in its outermost shell? Nitrogen has 5 electrons. And it has to have 8 electrons. That means it gains 3 electrons. So that many pairs of electrons will be shared. So that's 3 shared pairs. That means it becomes a triple bond, right? So this is a triple covalent bond. So this is how it looks like. And if you want to draw the final forming structure, this is how it looks like. Okay, I hope you understood nitrogen. Next, we come to methane. Now, methane also very simple to remember. Just know the basic formula for methane. CH4. CH4 is the formation of methane. That means there's one carbon and four hydrogens, right? One carbon and four hydrogens. Now carbon, everybody knows that carbon has four electrons in its outer shell, and hydrogen just has one electron. So since there's four carbons here and one electron, one hydrogen here, we can easily just form various pairs, and this is how the overall structure will look like. Quite simple. Next we come to carbon tetrachloride. Carbon tetrachloride is CCl4, right? The basic valency rule. Carbon has a valency of 4 and chlorine has a valency of 1. So this is basically a polar covalent, right? This is a polar covalent. So it looks kind of like this. It looks complex, but it's actually very simple. Just start from the basics. Carbon. Carbon has how many electrons? Carbon has 4 electrons, correct? Similarly, we have chlorine. Chlorine has how many electrons? Chlorine has 7 electrons. So since it's CCl4, there's 4 chlorines involved here. 4 chlorines involved. So this is how, so there's one. So one electron of carbon will go to one chlorine, right? This is the first chlorine. Second electron of carbon will go to the second chlorine. Similarly, third and fourth electrons of carbon will go to the third and fourth respective chlorine, right? So this is how you basically form the carbon tetrachloride thing. It looks sort of like this. So ammonia is not given over there in that list, but you know ammonia is very easy. So first of all, let us draw ammonia together. So what is the basic chemical formula for ammonia? Everyone knows that ammonia is NH3, correct? Ammonia is NH3. How many electrons does nitrogen have? Nitrogen has 5 electrons in its outer shell. Keep in mind we are not considering the first 2 electrons. We are just considering the electrons of the outer shell. Similarly, hydrogen will just have, since it's H3, that means 1 electron, right? This has 1 electron. And as I told you, 5 electrons in the outermost shell. 2 electrons here. Only 3 electrons we are going to consider for, you know, bonding, right? Similarly, we have hydrogen. 1 hydrogen here, 1 hydrogen here, and 1 hydrogen here, right? I'll take another color for this. So, how many electrons does this have? This has 1 electron, this has 1 electron, and this has 1 electron. So, let me redraw it. That's pretty bad. So, this is roughly what your ammonia bond looks like. It's pretty easy to remember, right? This is the ammonia bond. So, how many lone pairs are there? There are 2 electrons that are left, so there's lone pairs. So whenever you're asked in your examination how many lone pairs does this particular bond have, how many lone pairs does this have, how many shared pairs does this have, don't panic. Sometimes all you need to do is you just have to draw the bond and then you just calculate how many lone pairs. If you practice these different bonds that you have, right? Your ionic bonds, especially your covalent bonds. If you practice these bonds, I can guarantee you around 3 to 4 marks. Similarly, if you practice the orbital structures of all your elements and all, again you can get another mark. And just practice the theory from this chapter. This chapter doesn't have too much weightage also, but it is very scoring, especially for identify X, Y, Z. They'll say X element X combines with this element and forms a bond that has this many lone pairs, this many shared pairs. Because ICSE loves giving identify X, Y, Z type questions, right? So if you know this chapter and you know the periodic table, any of those X, Y, Z questions, you'll be able to master them, and then you'll be able to ace any exam that you rank. We've already done the periodic table, and now we've covered bonding. Next video, what we're going to do is we're going to do another very easy chapter, which is gas laws. Okay, we're just going to solve some of the sums in gas laws. I'm going to tell you some tricks on how to calculate them very fast, and then after that we can do chapter 3 actually. We can do water, and then we can also do hydrogen, okay, depending on what you think that we should do. So yeah, that's all for today. Thank you for watching. Bye.